You are welcome to Industrial Excellence Center by R. Lakshmanan. Through this video, you will be able to understand as how to practice AM pillar, that is JH pillar, effectively. What is AM or JH? JH is JISHU Hosen, which is a Japanese word. The equivalent English word is autonomous maintenance. Therefore, it is called as AM pillar or JH pillar. Before going into details, a brief note about me. I have implemented excellence in manufacturing practices starting from 5S up to WCM, that is world class manufacturing. And my experience goes with tires, auto components and footwear. We all know clean machine is a reliable machine. Clean machine will give us more quality stable output. And we achieve this through small activities on a daily basis. This requires a kind of culture among all employees in any company. What is that culture? It is I operate, I inspect, I maintain and I own the machine. How do we develop this? We can practice this, we can develop this through TPM autonomous maintenance, that is AM pillar or JH pillar. Subsequent slides, let's see as how to practice this. Let's see as why to practice the JH pillar. Why at all it is required? If we need to implement world-class manufacturing, through that we will be able to get much better effectiveness, efficiency in any company. We need to involve the entire team. To involve the entire team, that is the total employees, we need to have some structured system. Unless we have some structured system, we will not be able to involve the employees as a whole. And JISHU Hosen, that is autonomous maintenance, is one tool which will help us to involve the entire team. Therefore, it becomes important, necessary to practice JH pillar. Now, before going into the concept of JH pillar, it is necessary to understand a little bit of basics of TPM. We have given some kind of basics of TPM in our PM pillar video, where we have dealt in detail about OEE. Here, we would like to see certain basic things of TPM which is required to understand for implementing JH. We all know TPM has got 8 pillars which is listed here. That is autonomous maintenance, plant maintenance, quality maintenance, focused improvement, which is also called as Kobetsu Kaizen, early equipment maintenance, which is also called as development pillar, education and training, ENT, safety, health and environment, C pillar, and office functions. Of all these 8 pillars, though all the pillars are very important for improvement across the organization as a whole, the first 2 pillars, autonomous maintenance pillar and planned maintenance pillar, they are the core of TPM. If these 2 pillars are not functioning, if they are not effectively in practice, then we can say then the company is not following TPM. If any company can say the company is following TPM, these 2 pillars being the core should be practiced very well. Out of these 2, planned maintenance pillar, we have published a separate video already. You may go and visit that video to understand as how to practice planned maintenance. In this video, let us understand autonomous maintenance, that is JH pillar. Before jumping into JH pillar implementation, let us understand quickly, briefly, as how to implement TPM as a whole. Why it is required? This will help us to understand where the JH pillar is positioned in TPM. Thereby, we can understand the importance of JH pillar. How to implement TPM? As a company, if you take this in total, covering all areas, it may be difficult. We may not be able to implement quickly. Understanding may not be that clear. Sometimes people may lose their interest. They will get, they will not have that kind of energy to continue. Therefore, the normal practice is to select a pilot zone or a pilot machine. What kind of pilot machine should be selected? The machine should be simple. Therefore, we can implement TPM quickly. The machine should also needs debottlenecking. Therefore, we can show some significant results. Or the machine with low hanging fruits. When we select these kind of machines for pilot, we are able to implement quickly. Therefore, there is a success in implementing TPM, and we are able to show a good significant results which will easily motivate other team members, and we can spread TPM across the country, across the company easily. Having selected pilot machine, these machines are anyway running for long, so there will be some natural wear and tear. So anyway, these machines therefore will not be operating in a normal way, in an optimal way. They will be functioning or giving results in a suboptimal level only. Therefore, it is necessary to restore these machines back to original condition. That is called as basic condition. If we are able to restore this back to original condition, we will naturally get better results from these machines, both in terms of stability as well as productivity. How to achieve this? It is done through 5S and JH pillar. This is where JH pillar is positioned in TPM. You can see now JH pillar is most important to start TPM. Without JH pillar, you can't even imagine TPM. Okay. Now to start TPM, it is necessary to have basic housekeeping in place. Therefore, 5S implementation becomes the foundation of TPM. 5S implementation is a foundation of world-class manufacturing itself. Now, for how to implement 5S, we have already published a separate video showing step-by-step implementation of 5S. Those of you who are interested can visit that video and understand 5S in full. JH pillar, that is AM pillar, let's understand in this video. Now to restore the machine back to original condition, that is basic condition, only JH pillar is not alone not sufficient. PM pillar is also important. PM pillar and JH pillar both have to work hand in hand. When they work hand in hand, we will be able to restore the machine back to original condition, and that is the major goal of JH pillar. So PM pillar, understanding PM pillar is very important. We have already published a separate video for implementing PM pillar. You may visit that and understand it. Now, PM pillar is in place, AM pillar is in place. Therefore, it is time to improve the efficiency of the company as a whole. Where all there is a loss, we should be able to now quickly recover those losses or stop those losses, for which we need to implement Kobetsu Kaizen, that is KK pillar and QM pillars. The fourth one is PM pillar, which we already spoke. And PM pillar is very, very important because it is the one which helps us to achieve zero breakdown or reduce the breakdown to a negligible level. Also, it helps us to extend the life of the machine, which means it reduces it eliminates, it avoids the capital investment itself, which is very important for the company. After this, other pillars can be taken up one by one as we move on. Now, now we are in the process of implementing TPM. Let's say we have implemented. How to monitor the progress of TPM? To monitor the progress of TPM, there is one most important parameter which is followed in TPM. It's a kind of new terminology. It is OEE, overall equipment efficiency. We have to track this. We have explained OEE. What is OEE? How to find out this? How to calculate in our PM pillar video. Please visit PM pillar video to understand OEE in depth. Understanding OEE in full is more important, rather most important, to practice TPM. Let us understand as what is JH, what is AM. It's basically a mindset change, a cultural change. All of us will have either a two-wheeler or a four-wheeler, some vehicle will have. What do? Normally, we do cleaning of the vehicle. We'll check air pressure of the tire. We'll check the fuel level. We check brake condition. These are all minimum basic requirements we regularly check. Therefore, the vehicle runs without any problem for us on the road. Same thing. Same things expected in a company with the operators. Because as we all know, our two-wheeler, four-wheeler more closely, more better, as we have been using it regularly, the machine operator who are operating the machine, who are with the machine always, they have been always observing the machine, they know better. Suddenly there is some noise coming, they will keep on observing. Their ears and eyes are open because they are operators. So if they also start doing a basic maintenance activities, like we are checking air pressure, brake checking, all that, then that particular machine will run forever or will run for long, and it will not unnecessarily get deteriorated. We can prevent further deterioration. So, to implement JH, therefore we need to have a kind of mindset change. So far, in a company, when an operator is operating the machine, he operates. If there is a breakdown, he leaves it. He calls the maintenance fellow and asks him to do this. So, I operate. Better you maintain. Now, mindset changes slightly. I operate. You also come. I will also do. Let us maintain. Both of us will maintain so that we can succeed. So the mindset changes. I operate, you maintain. 2, I operate, we maintain. That means it promotes a kind of self-maintenance. The operator is able to do small jobs or basic jobs on his own. So it promotes self-maintenance. By doing this, he helps the maintenance team. Then now machine will not get deteriorated. Frequent breakdowns will not be there, or minimum things are taken care. So the maintenance team now can focus on real improvements of the machines, like bringing big changes so that the machine can run for a long time, or the machine can help us to give better output, things like that. Means maintenance team can now focus better on the real improvement activities. Okay, for implementing JH, there are some basic requirements. Let's see what are those. All those operators who are operating on a particular given machine should have basic knowledge about that machine functioning. There will be some lot of important parameters, key parameters of those machines. The operators must know about those parameters in an ideal condition, and when it is functioning, how those parameters should look like, which will help them to identify if there is any deterioration or malfunctioning. Also, they should have a knowledge and skill set of doing some minor repairs. If there is a minor repair, they should be able to do it, correct it on their own, for which they should be given sufficient training, which we can see in the subsequent slides. Which means operators will own and accept that this machine is my machine, and if there is some minor repair, I must be able to do that repair and maintain it. Which means it is basically a cultural shift. Like what we saw earlier in the previous slide, I operate, I maintain, I take support from maintenance department, and therefore we maintain. So that kind of cultural shift is happening in JH, which actually helps us to prevent forced deterioration. Now let's see how to implement and practice JH, that is autonomous maintenance. It's popularly called as 7-step approach. If we consider step 0 also, it is actually 8 steps. What are those steps? Step 0, preparation. Step 1, initial cleaning and inspection. Step 2, eliminate source of contamination and inaccessible places. Step 3, establish tentative JH standard for implementing CLIT. Step 4, conduct general equipment inspection. Step 5, autonomous inspection. Step 6, standardization. Step 7, autonomous management, that is self-management. Let us see what are these steps in detail so as to practice it effectively. Now let us see the 0th step, that is preparation. For implementing any project, we all know it is necessary to have a plan, and that is what is preparation. In preparation, the initial activity is team formation. Without a team, no single man can implement any system. All of us know this. Now to implement TPM as a whole across the company, one has to drive. We said there are 8 pillars in previous slides. So all the 8 pillars have to be driven. So we need someone who can coordinate all these 8 pillars and drive them. Therefore, it is necessary to have a TPM coordinator or a manager, whatever the way you call it. So here we have said TPM manager. He will have a small administrative setup under him. I have not mentioned that here because our interest is to understand JH pillar implementation and not TPM as a whole in the company. Now, TPM manager will have his representation across all 8 pillars. Now, what we are seeing here is AM pillar or JH pillar. So, JH pillar will have a head. That head is called as AM chairman or JH chairman. We have to understand this is not an additional role. We don't have to recruit a new person, additional person to implement JH in the company. Normally, since this autonomous maintenance or JISHU Ocean is dealing with employees, workers of production operators of that machine, the production head, manufacturing head will be always taken as JH chairman. That means that production head will have now dual role. He will do regular production head, that role, and this JH chairman role so as to drive autonomous maintenance across the company. Now to assist him, you will have team leaders. Why? There will be normally multiple sections in any company. So every section to be focused. So every section will have a leader, and that person will be working in that section only. He will have good knowledge of that section or that machine. So there will be a team leader. Under the team leader will have a team to implement JH. What is this team? This is the team, those people who are directly working on that particular machine. It can be production operation or a quality person who is assisting to produce good quality products, or a maintenance person who assists them in set writing the machine as and when there is some repair, or it can be an engineering or technical person who comes and resolves if there are some engineering related issues or technical related issues as we start production. So a combination of all these people. Main members are production operators, and they are supported by this maintenance, engineering, quality operators. This becomes the team. This team reports to team leader, and the team leader reports to JH chairman. This is the setup. And all these people, they are all already working in the company. None of them are new resource. The only new resource will be the TPM manager and maybe a minor administrative setup that is required. All other team members are existing team members. Initially, as we start, it will look as if they are doing additional job. In a short duration, that will get vanished. It becomes a normal activity. That much we should have a clarity in our mind. Okay. Having said that, now team is formed, team is ready. Next is where to start. In previous slides, we said we have to select pilot zone or a pilot machine. And we also said this pilot machine should be a simple machine so as to implement TPM quickly, and we should be able to get significant result from that machine. Then only we will be able to motivate other team members of the company. That is one method to select pilot zone, pilot machines. Also, it can be selected through ranking of the machine. How to rank the machine? We have explained ranking of the machine in our PM pillar video. Please visit PM pillar video to understand as how to rank the machines. So we can also select these pilot machines through this ranking. Now we have selected the machine. Machine is ready, team is ready, machine is ready. Now we need to implement JH. So it is necessary now to have a plan. Without a plan, we cannot implement. So it is called as master activity plan. It's a broad guideline. It's a time-based chart. It's a time activity chart or a Gantt chart. You don't have to be very strict about the timing. It can be a broad guideline. Make it. As we move on, we can fine tune it. There is no hard and fast rule to have a strict timeline on this plan. Now we have team ready. Machine is selected for implementation. Plan is also made ready. Time chart is ready. We have to start. But before starting, one has to have the knowledge. We said we are going to involve the entire team, right from workers up to the manager, head of operations. All people are going to be involved in this. So to involve them, it is necessary to give training. So we give training. Now with respect, when we come to JH, when we restrict this training only for JH, it is necessary to understand what kind of training to be given for JH. We said the very main goal of JH is to stop forced deterioration, restore the deteriorated machines back to original condition, that is basic condition. So if you have to restore back the machine back to the original condition, we need to understand what are all the kind of abnormalities that is there at present. Unless we identify what the abnormalities, we will not be able to correct it. So we need to give training as what are abnormalities, how to correct them, what kind of system to be followed. And to now, in a simple sense, what is abnormalities? Anything which is not behaving in a normal way is abnormal. Therefore, there is abnormality. So therefore, to understand this, one has to have some good knowledge of that machine also. Therefore, we have to give training to the operators on a complete working principle of the machine. Operators should have 100% knowledge of the machine operation. Then only he will be able to quickly understand what is abnormal, what is to be corrected, whenever there is a problem, what to correct. Every machine, when it is getting operated, when it is in operation, there will be a lot of safety parameters. So it is necessary to give training on safety parameters also. Now actually we need to prepare a good training manual to train them. I am not going to details of the training manual here in this presentation. Most importantly, working principles of the machine, how to correct minor repairs, and what are all abnormalities, how to find out those abnormalities. This kind of training we must give. Without this training, we cannot proceed further in implementation of JH. After doing this, we need to set the targets. We cannot implement JH for just for the sake of implementation. No. For anything, we need to get the benefits. So there are a lot of benefits which you are likely to get in JH. I am not dealing about those benefits to start with. As we proceed, we will understand better. So I have kept this target setting at the end of the presentation. So we'll understand as what are the targets at the end of the presentation. But target setting is also very important at the beginning itself. We said we have to identify all abnormalities and we need to take corrective action so as to bring the machine back to original condition, that is basic condition. So now how to identify abnormalities? What are abnormalities? It is also called as fugi. It's only a name, don't worry about that. Anything which is not normal and it is abnormal, therefore it is called as abnormalities. These abnormalities will have negative impact on all key parameters of production, be it productivity, quality, cost, delivery, morale of the employees, and safety. In all this, these abnormalities will have negative impact, and therefore our operational efficiency as a whole will be declining. Therefore, it is important to identify these abnormalities and correct it. Now, how many types of abnormalities are there? There are 7 types of abnormalities. Minor flaws, unfulfilled basic conditions, inaccessible places, sources of contamination, sources of quality defects, unnecessary items, unsafe places. These are the 7 abnormalities that are existing in any company. All abnormalities will fall into one of these 7 categories. We should identify these and correct them. Let's understand more about these abnormalities in the next slide. Let us try to understand how to identify abnormalities. We said there are 7 types of abnormalities. In this slide, we are given left side all those 7 types of abnormalities. The right side, a kind of guideline indicators are given. Identifying abnormalities is very important. Kind of skill is required. It is not that anybody can identify abnormalities. Certain abnormalities can be identified by anybody. But for identifying all critical abnormalities, some kind of training is required and we should not miss out any of those things. Therefore, I suggest you make a checklist based on this guideline. Based on this guideline, keeping the machine configuration in mind, one can easily make the checklist which can be used well during inspection for identifying abnormalities. Okay, let's try to understand few of them from this slide. The first abnormality listed here is minor flaws. The name indicates minor flaws means small mistakes. How to identify that? Indicators are play, slackness, crack, crush and damage. Like that. Let's take a small example. Let's say crack. There is a shaft. The shaft is fitted with the two bearing blocks and bearing blocks are fitted with the 2 bolts each. In one of the bearing housing, that bearing block neck area, let's say there is a minor crack. If it is not inspected and identified, then this crack will get developed further and the bearing block will naturally break. If it is broken, the shaft is anyway fitted with only 2 bearings. One bearing now fitting is out. What will happen? I don't know to explain. You can imagine. So that is the kind of importance. It's only a minor flaw. It's a small mistake, minor crack. But if it is left unattended, if it is not identified on time and the action is not taken, we are under loss. Let's see the another one. Unfulfilled basic condition. A machine is supposed to have certain components with it. Something is missing in this. Basically, it's getting missed. Therefore, it is called as unfulfilled basic condition. What are those? Dirt. Machine is supposed to be clean, but there is a dirt and dust. Machine should be leak free. Leak is there. Like that. Leak, looseness, parts missing, wrongly fitted, wrongly threaded, etc. From here also, let's take one example. Let's say parts missing. Assume there's a pipeline. It is fitted with a small 4-bolt flange. Let's say one bolt is missing in that. Only 3 bolts are there. So what will happen? Sooner or later, that flange will give out whatever the media that is going on there, maybe air, maybe water, maybe oil, whatever, it is going to leak soon. So that is the importance of parts missing. So like that, one has to go through this in full, use these indicators, guidelines, make a checklist pertaining to the machine which is to be inspected. All this will not be applicable for all machines. These are only guideline indicators. Using this, prepare a good checklist so that when the machine is inspected, we don't miss out any of these abnormalities. Number 1. Number 2, it is very important to take some examples of these abnormalities and train all the employees connected with that machine. One has to understand these abnormalities very clearly. Clarity should be there in their mind. Then only they will be able to identify the abnormalities. Unless they identify the abnormalities, we will not be able to take corrective step. In that, if the corrective step is not taken, we cannot restore back the machine to original condition, that is basic condition. Therefore, in JH implementation, this particular step, identifying indicators, abnormalities is very important. Give sufficient time, prepare a good checklist for inspection based on this guideline. We said in JH, production operators play vital role. In the beginning itself, we said the cultural shift. I operate, you maintain. from this thought process, there should be a shift to I operate, we maintain, which means we are expecting production operators to hold some responsibilities. What can they do? What a production operator can help in this? Number one, they should be able to identify abnormalities. They can sense it because they are with the machine continuously. They know the machine much better than others. Always the machine is under their eyesight, so they can easily identify. Examples: loosen bolts. It can be even by seen by eyes, or it can be by feeling. By touching itself we can identify. Abnormal heat and vibration. Vibration will give out some noise also. Heat generation by touching we can identify. Air leakage and machine noise. Abnormal smell. The heat is more, there can be some burnout smell. In fact, all these things will be very clear for a maintenance person who is working there, and these operators who are working there in that machine. Not to exaggerate, they will be knowing much better than even the maintenance team members there. So they can easily identify all these things. Therefore, we should take help of these production operators from these aspects. Okay. Now, having identified this, they can also do small corrections, small maintenance activities. What are they? Cleaning. Unless you clean the machine, these abnormalities cannot be seen. As we clean, we can even find out the loosened bolts, air leakage, this heat, vibration, these things we can easily identify. So we expect them to do cleaning, inspecting of those parts, important components, lubricating their equipment. Lubricating takes few seconds. It's not going to take a long time. So we are not going to lose out any production operation time because of this. Retightening of loose bolts. As they do cleaning, they also see some bolts loose. It will take half a minute, few seconds for them to tighten that. By that, we can eliminate major breakdowns. So these are all the small activities, very minor activities. Production operators can do easily without the support of maintenance of a team. Thereby, the machine can be operated long without any problem. Most important. Okay. Now we have come to step 1 of JH. In step 0, we have seen it is full preparatory activities. We have fixed the team. We have located and identified pilot zone, pilot machine. For that area, people were given sufficient training on JH, in particular about the machine working principle, identifying abnormalities, what are abnormalities, how to correct the abnormalities. On this line, enough training has been given in step 0. Now we are starting the real JH implementation. The first step is initial cleaning and inspection. The name indicates initially we are going to do cleaning. Starting with, machine will be looking very dirty. We may spend quite a good amount of time to do good cleaning. After initial cleaning, machine will be neat, and there will be a system to take care of the cleaning aspect also. Therefore, it will not take much time to clean. Therefore, the important word initial cleaning, clean. Now, cleaning is inspection. Clean and inspect. Cleaning is also inspection. As we clean the machine for dirt, dust, let's say when we are cleaning, we may see some leak points. When we clean, we may see some loose bolts. When we clean, we can see some guard rubbing with moving parts like chain, belt, gear, etc., etc. So as we clean, we can also identify abnormalities. In step 0, we already given training to these people as how to identify abnormalities. Now they have that knowledge. Now while they are cleaning itself, they can do inspection. As they find out these abnormalities, we should not miss out anything. Therefore, we also said during understanding of 7 types of abnormalities, we should make kind of checklist. Use that parameter, use that guideline for making a checklist. So make a checklist showing pictures of the machine parts. Why this is required? So that we don't miss out anything or we don't do checking at the wrong location. It is very important to make a tentative checklist with a picture. Therefore, communication is correct. We don't do any miscommunication. And when you are preparing initial checklist, it is a tentative checklist. You don't have to spend more time on this in preparing good checklist. As we move on, the checklist can be always fine-tuned and corrected. Okay. As we do this, we are identifying abnormalities. We said these abnormalities have to be tagged. Why it should be tagged? Then only we will know if more number of tags are hanging, more problems. It exhibits, it displays directly. So as we walk, when we see more tags, we can understand the machine has to be corrected. More problems are there. So we can keep on monitoring some problems through eyesight itself. Therefore, tagging is important. Okay. Now, how many types of tags are there? There are 2 types of tags. One white tag, second one is red tag. White tag is for minor problems. For example, there is a nut loose. It just not be tightened. It might take few seconds. So that is white tag. Like one more bolt is there. Bolt nut tightened is there. That bolt is projecting out of nut. That protrusion can be, let's say, 2 threads or 3 threads. Maximum 4 threads, let's say. Definitely not more than that. In some cases, it can be 10-15 threads also. So where it's also a minor problem, you just have to remove that bolt and change a new bolt, or remove that bolt, correct it and put it back. Why it is required? Whenever there is a breakdown, you need to remove that nut for such a long distance. It will take long time. So we'll be wasting time. Therefore, maintenance repair time will be more. So it is very important to have projection of bolt beyond nut with only 3 or 4 threads. Definitely not more than that. So such areas we have to put white tags. These are minor problems. These minor problems can be corrected, attended by production team themselves. Therefore, it is white tag. Because they have been trained now. We have given training to them. They can do this correction. Now, there can be some problem which cannot be attended by the production operators. Example, let's say there is flange mismatch. It is not aligned properly. Alignment error is there. That has to be corrected by maintenance team only, because it requires a different level of skill set. So where you will put red tag. So at the end of this exercise, all the abnormalities would have been identified, and abnormalities would have been tagged with either white or red color. So these tags will be hanging here and there. To streamline this, we can put the tag in a board also, or we can hang the tags in a tree form. Different companies follow different methods. Any method you can follow. The point is, we should not miss out any tags. Also, for future records, it is important to log all these abnormalities in a logbook. Either, see, starting with, it has to be on a logbook, physically written in the shop floor only. Later on, you can put in your computer also in these days. But it is very important to keep these records at site near the machine. You can't say that I will show in my computer. No. Physical record, physical tags should be seen. As we move, we should be able to understand the progress by seeing the number of tags. We don't have to even count. As we move, we can see. These records will help us to see the progress as we move on. Okay. Now, in case there are some missouts in training, in 0th step, ensure training in this step without fail. The production operators should be able to understand well about abnormalities, correcting these abnormalities, and what kind of support they can give to maintenance team. So from this point of view, a good amount of training should be given. Okay. Now, these abnormalities are getting corrected, we said. Some are corrected by production people, some are corrected by maintenance people. As they correct, it is necessary to find out root cause of that. If the nut is loose, why it is loose? Because correction is easy. You just have to tighten it, it will take only a few seconds. Once again, the problem can come. So we should not allow it to repeat. Therefore, it is necessary to understand why the abnormality is. So this analysis can be done through YY analysis. It is given in our PM pillar video. Please visit our PM pillar video to understand YY analysis in detail. Based on the root cause, take action. Sometimes it's only corrective action. Sometimes after correcting it, it may be necessary to capture it, to bring it in our preventive schedule so as to prevent this in future, which we will see in detail as we move on. Now let's see second step. Eliminate source of contamination and inaccessible places. What is the importance of this step? In step 1, we have identified abnormalities and we have also taken corrective action. Now, abnormalities are not there. At the end of step 1, there are no abnormalities. All are attended and corrected. If there are few abnormalities left, it may take long time to correct it. You would have recorded and you would have made some plan to correct it. Then you can move on. So it is in that level, which means for all practical purposes, there is no abnormality at present. So this condition should be retained at that level. No, machine should not go back to that initial bad condition. It should not go back. So to prevent that, in the step 2, we start identifying the real source of contamination. For example, if there is a leak, yesterday we have corrected, today again it is a leak. Again you are correcting it, again there is some leak, it's coming. Or there is a dust. Yesterday we have cleaned, today also we see some dust. Dust should not be keep on coming every day, no. So if it is coming, there is something else is there, from some source is there, from that source the dust is coming. So one has to trace back to the source, the root cause, and identify that. That is what is map the area of contamination, trace back to the source of contamination so that you can attack that point. While correcting that source of contamination, keep in your mind always Taraka mantra: eliminate, reduce, then localize. Which means first priority, I have to eliminate the problem. If there was a leak, that leak should not come back once again. Once and for all, I should eliminate it. Sometimes it is not possible to do so. For XY reason, I am not going into those kind of reasons. Then at least try to reduce the impact of the contamination. So that if I have to do the cleaning, instead of cleaning every day, I can clean once in 15 days or once in a month. Reduce the impact. Even that is not possible, at least localize. That leak should not spread across big area. If it is getting spread big area, it is also a big safety concern and it will contaminate many points and probably it will result into quality issues also. Safety issues will be there, quality issues will be there. Therefore, localize it. If there is a leak, at least collect it in a small area if we are not able to correct it. The first priority is to eliminate the problem. If we are not able to eliminate the problem, at least minimize, reduce the problem. If we are not able to reduce the problem, then localize. This is the Taraka mantra. Based on this, we should map and identify the source of and correct the source of contamination. Having done this, now all the machine parts we have to maintain to avoid forced deterioration so that the condition is maintained well, for which it is important to implement a concept called as CLIT sheet: clean, lubricate, inspect, tightening. Of course, this is going to be implemented in step 3, for which in step 2 it is necessary to prepare, to do some preparatory activities to implement CLIT sheet in step 3. So what kind of preparatory activities? We said clean, which means I should be able to do clean in no time, within few seconds. I should not spend more time. So I should be able to approach the machine easily. And if there is some dust that is coming, I should ensure that dust is not coming. Therefore, cleaning I can do only once in 15 days or once in a month. I need not do cleaning daily. From that angle, like that, for cleaning, lubrication, inspection, tightening, for all these aspects, keeping this in the mind, in this step, take action. Like lubrication is taking more time, or I am not able to do lubrication. Why? I am not able to approach the place itself. So take corrective action. Something like that. So keep doing this in this step. To do this, it is necessary to make some kaizens. Like if you are not able to approach a machine component for inspection, then I will not be able to do inspection. Then I cannot implement CLIT, CLIT inspection. I cannot implement. So I have to make that area approachable, for which I will do some alteration of machine components or surrounding areas, whatever. Which means you are making an improvement over the existing system. Any small improvement is called as kaizen. How to make kaizen, how to record this, full details is given in our PM pillar video. Kindly visit PM pillar video to understand more about kaizen. Okay. Now we have done corrective steps like this. We have to communicate this. We have to train the people for us to maintain this. So sometimes it is necessary to develop OPLs, 1-point lessons. So during this step, we will make 1-point lessons and kaizens. 1-point lessons are used for educative purposes. Till yesterday, machine was in X configuration. Now to make that part more easily accessible, approachable, we made some alteration and we implemented Kaizen. Therefore, the machine is now taken Y configuration. So job what we have been doing when the machine was in X configuration will not be required in Y configuration. Something else will be required. Sometimes no job will be required. If you eliminated the problem, no job will be required in Y configuration. If you are not eliminated the problem, you have implemented a Kaizen only to reduce the problem. We said eliminate, reduce, localize. If you eliminated the problem through Kaizen, then OPL will not be required. If you are not eliminated, you only did the other two activities, reduce and localize, then it is necessary to communicate, train the local people who are working there. It is important. They should have that knowledge. So you will develop OPS. Name indicates 1-point lesson, which means that display should have only 1 point, nothing more than that. We will see more about OPLs in subsequent slides. Now, the machines have to be clean, the machines have to be lubricated, the machine parts have to be inspected. All these things we are going to do in next step, for which in this step one has to spend time and understand what kind of frequency that is required. Means basically this step is a preparatory step for the step 3, and whatever improvement we got in step 1, we need to maintain that without any further deterioration. That is the purpose of this. Therefore, this step is called as eliminate source of contamination and inaccessible places. In this step, let us understand how to make a OPL more effective. OPLs are very, very important for communication. We can do a lot of success stories by using effective OPLs. Any change, any Kaizen that we brought into the system requires to be communicated, educated. Some Kaizens will not demand any OPL because you would have eliminated the problem. Thereby, there is no necessity for us to communicate on a regular basis. Whereas, there are some locations where Kaizens would not have eliminated the problem but reduce the problem. One, while reducing the problem, it would have brought in some other new system into practice, so which has to be communicated. So in all this sense, communication should be effective. How to make it effective? By having correct display in front of them. This is done through 1-point lesson. The name indicates that communication should be simple, only 1 point. The best communication, the best OPL, which all of us are seeing in our day-to-day life, is our signal system on the road. We see in our signal, what we see, there are only 3 lights, red, yellow and green. Red stop, yellow wait, green go. This, as we move on, we understand this. Because we don't have to read and understand. One color, only 2 letters, 3 letter word. We don't have to spend time to read. Then only it will be effective. No employee is going to stand and read your OPLs to understand. As we move on, we should be able to communicate. Nobody should stand and read. As they are walking, they should be able to capture it in their eyes. As I'm working in a production line, in front of me, whatever OPL that is there, I must be able to understand it in few seconds. I will not be reading and understanding. As I see, I should be able to understand. That is the most effective way of publishing OPL. That is the example here we have given. So how can it be more effective? It should be pictorial, maximum 5-6 words only. The 5-6 words reading will take no time. And it should be bold enough to read quickly. Best one is, as we walk, we should capture our eyes. We should not stand and read. And for which we should not be spending more time. Few seconds, 5 to 10 seconds only. If we follow like this and make a good pictorial OPL, it will communicate what it has to communicate. What we intend to communicate will be communicated positively. Thereby we get the results. If we don't follow this, I have seen many places OPLs with made in sentences. It all will be namesake OPL lying there, displayed there. It's only waste of money. I can openly say that. It is not going to be effective at all. They are all SOPs rather. Standard operating procedures, SOPs, on which you have to give them training. You convert them into few words, make it OPL, even without training they can understand better. Please keep this in your mind. Try to make OPLs with few words, high catching, pictorial. Nobody need to stand and read. As they walk, they should be able to capture it. Then OPLs will work effectively. It can do wonders. We said in step 2, it would be required to do some Kaizens and OPLs. There are some ideas given here, general ideas, and these are commonly used across industries for doing improvements. And these improvements are never stagnant. You can do one improvement today, same improvement can be changed maybe after a month. So like that improvement keeps on happening. The purpose is how to reduce my click time. The production operators have to spend time to do click activities. Clean, lubricate, inspect and tighten. I have to reduce that time. How to reduce? Kaizens will help us a lot in that. Example, rotating part covers. If the cover is made of metal, what is inside that running part, moving part, we will not see. If it has to be inspected, we have to remove the cover, then only we can inspect. Instead, if it is made transparent, without disturbing the cover, we can see that. In some places, it may be possible for us to put transparent cover, or at least at the inspection point you provide transparent cover. This will help us to see the moving part condition, how the gears are getting meshed, how the chain drive is there, how the belt drive is there, what kind of slackness is there. By look itself we will understand is a time for correction. Fasteners, like nut and bolt is tightened. Is the nut loose? Just by seeing we can understand. After tightening the nut, by putting a mark line on the nut and on the fixed frame. Nut is movable, frame is fixed. The line marking, it is mismatched. It is understood that it is loose. So like that, there are some ideas given here. These ideas will come through YY analysis. How to do YY analysis? We have explained this in detail in our PM pillar video. Kindly visit that. After doing YY analysis, we do corrections that is captured through Kaizen sheet. How to record it? Why Kaizen sheet is required? All these things are explained in PM pillar video. See that and understand. We have now come to step 3. Before going to details of step 3, a brief summary of what we have seen so far. Step 0, step 1 and step 2. In these steps, we said we'll have to form the team, select the pilot zone or pilot machines, try to give good training to all the employees concerned on what are abnormalities, how to correct abnormalities. As we identify abnormalities, what kind of correction to be done, how to monitor this through log system and tag system. As we identify abnormalities, how to do corrective action, we need to do root cause analysis, tracing back to the source of contamination. That will give us the root cause. We follow YY analysis for that. As a result, we start making a lot of Kaizens and generate OPLs. At the end of step 2, through this system, at the end of step 2, we have reached a stage where there are no abnormalities now. All the abnormalities are corrected, which means the machine is now restored back to the original basic condition. Maybe one or two abnormalities can be there, which may take long time for correction. So probably we could have taken a target date for that, giving some timeline, fixing target dates for those things, then move on. For all practical purposes, at the end of step 2, almost all abnormalities are now corrected. So now we are entering step 3. Having corrected all abnormalities, the machine is almost brought back to the original basic condition. It is now our duty to sustain the improvements what we got. How to sustain those improvements? It is through a system called as CLIT. That is clean, lubricate, inspect and tighten. Some companies do call this as CLRI also. That letter T is replaced with R. T means tightening, R means retightening, all are same, no need to worry. In our discussion, we have taken it as CLIT. Okay, how to do this now? We need to inspect the machine. Wherever small corrections are there, we need to keep on correcting it. And we'll have to ensure that these clean, lubricate, inspect, tighten, these activities are regularly carried out by the employees, workers of that particular machine, so that the machine is maintained, improvement is sustained, it will not get deteriorated. So it becomes necessary to make a standard for inspection. So this standard initially when we make, we may not be able to make the correct standard. So initially we can make a tentative standard, and as we move on, we can fine tune it and correct it. As we make this tentative inspection standard, involve workers also. There are two important aspects of this. One, workers do have good knowledge about the machine. So discuss with them, involve them so that you can identify the critical points for inspection, number 1. Number 2, as we involve them for making inspection sheet, inspection standard, it becomes easy for us to implement. At the end, workers are going to do this inspection. they are going to implement CLIT. So when they have to implement CLIT, if they are involved in making the sheet, all the more it is easy for us to implement. So never forget this. Involve worker in making CLIT standard. Now having made this, what are standards? Just for example, a particular oil to be filled as a lubricant. So we have to write the specific code of the oil, that becomes a standard. And how much oil to be poured, you have to indicate through level indicators. This becomes a standard. How to pour the oil, that becomes OPL. So you make this kind of standards. Against this, now you know the standard, we need to now inspect. How to inspect? We have to make a checklist. Inspection check sheet. What all to be inspected? Against which standard? The best practice is we make inspection standard, then inspection checks, then we do the action. If all these things are covered in a single sheet, it is excellent. If it is not possible, standard can be displayed separately and check sheet can work as a check sheet separately. No harm in that. Now we are ready with check sheet. We are ready with the inspection standard. Both are there. Check sheet gives the points to be checked. Standard gives the norm. Against that standard norm, we are going to do the check sheet. Correct? Right. Now, for the worker who are going to do this checking, CLIT, it should be easy for them. So let us say in a machine, there are 10 points where we need to do some cleaning, some lubrication, some inspection, some tightening activity, whatever the activity may be. So there are 10 points. It is always recommended, not recommended, it is a must. We should mark all these 10 points on the machine so that it is visible very clearly. It should be bold. It should strike our eyes. We should never miss out that. So as the operators are going for that inspection, in the check sheet, the point is 1. They should be able to directly go to the point 1 and do that inspection. In the check sheet, serial number is 2. In the machine also it is marked as 2. So they go and inspect that point. In the check sheet if it is 3, on the machine also it should be written as 3. So these kind of marking, visual marking is very important. And near that place itself, we should have a clear-cut display showing what to inspect, how to inspect. Normally, OPLs in such areas directly over the inspection point will be better. Now, that machine has got visual controls for CLIT. We have made the CLIT check sheet. Let us see how to make a CLIT check sheet in a different slide. I have given an example. So we have made the CLIT CLIT check sheet. We have also made a tentative standard. So against a tentative standard, whatever the points we have listed in the CLIT check sheet, we are going to inspect. These are also marked on the machines so that we will not miss out. One step beyond this, on the floor also we used to mark this so that we can easily trace that point. In fact, the flow of inspection pattern, inspect point 1, then to 2, then to third point, then fourth point, like that also on the floor there can be arrow diagram so that the operator can go in the same direction. They don't miss out. It is not that they don't know how to go move and inspect. If it is given daily basis, they will go in the same direction, which will reduce our inspection time. Ultimately, we have to reduce the time taken to do CLIT activity. let's say in the beginning, it may be taking, let us say, 10 minutes. It will come down as less, as minimum as even 1 minute. When we make these standards and make them to practice in the same direction. And as we move on, if it is taking more time, we can make some kaizens for that. Why it is taking more time? How do I reduce my inspection time? How do I reduce my lubricating time? If it is getting loosened and then again I have to retighten it, how can I eliminate that? Raising such questions as we are doing CLIT, raising such questions will help us to reduce overall CLIT time. The objective is we have to do CLIT, and at the same time we have to reduce the time taken to do CLIT. To that extent, we have to give them training also. Okay. Let us see here a model clit sheet. I have given the model clit sheet. You can modify this to suit your machine configuration. All of us know clit means clean, lubricate, inspect and tighten. Now when you make this, we have to keep one thing in our mind. First make a photograph or a drawing in a configuration form. It can be in block diagram also, no problem. And all the machine components, you name it. This is the minimum required. If you take a photograph of the machine, best. On that photograph, whatever inspection we are going to do, mark them. For example, here if you see clit sheet, the first serial number 1 and 2 indicates oil tank. So in the configuration drawing or configuration photo, you go and mark 1, 2 on the oil tank. More particularly, on the oil tank, 1 you will mark, 2 you will mark in the place where you are supposed to check the oil level. You see in the activity, 1 is clean the tank surface. So serial number 1 can be marked in any location on the surface of the tank, whereas serial number 2 to be marked and where you are going to check the oil level. So like this kind of points to be captured in a overall configuration drawing and displayed in front of the machine for education purpose, number 1. Number 2, each and every component of the machine, on that component, this point to be marked, so that there is no miscommunication. You are able to communicate positively, correctly. Okay. Now, example I have taken here, a oil tank with a hydraulic pump. There are many more points. I have not taken all those things. Just for example, I have taken oil tank and pump motor assembly on the tank. Now, oil tank, next to oil tank, you put the photo of that oil tank so that it is visible. Next to it, what are the jobs we are going to do? That code. Any job what we are going to do through this clit sheet will fall under one of these 4 categories, C, L, I, T. So now here, for example, if you see, the first activity is C, that is clean the tank surface. The second activity is L, check oil level. Oil is a lubricant, so L. Then you go next, we have given the standard. For C, clean the tank surface, the standard given here is no dirt, no oil trace. Tank should be clean, so no dirt. The next one, for oil level, we have given here standard as green zone. Oil level should be in the green zone. The oil level indicator has got yellow color, red color and green color. It should be in the green zone, it is given. So we have to make a color indicator there for to see that easily and put that picture here. so that it is immediately communicated. In no time it is communicated. So that is the standard. The next one, what is given here is, what are the tools required to do this check? For example, first one, see, clean. What are the tools required? You need your hand. You also need some cotton cloth to clean. And through our eyes, we have to see. So those are the tools required. So like that we make this. Subsequently then how much time it is required? Initially when we are giving training, we make this check sheet, we give training, you conduct the study. After conducting the study, you put this time. Here I have given example 5 seconds. As we keep on doing this our objective is it possible to reduce this 5 seconds to maybe 4 seconds, maybe 3 seconds, like that. Our goal is to do click. At the same time, keep on reducing click time. Do it effectively so that we don't waste time. So that is the objective. Now who will do this? Operator A I have given. So there can be multiple operators in the same machine working. So we have to assign the responsibilities. Sometimes machine is running only for one shift. There may be 4 or 5 operators in the same machine. So you accountability to all of them. So some job will be done by operator A, some job will be done by operator B, C, D, like that. Some companies which is operating in 3 shifts, shift A, shift B, shift C, you can give this responsibility splitting across the shifts also. Shift A operators, shift B operators, like that also you can give. It all depends on, it's just a plan. How do you want to implement it? You can plan and implement. There is no problem. Then you also give the frequency. Then last, I have given 30 days calendar. Because some jobs will have to be done daily. Some jobs will have to be done every shift. Some jobs you may be doing once a week. So accordingly, this sheet has to be followed. Somebody has to audit. That is the one in the last column, audited by. Unless we do audit, people may not follow this regularly. I tell you here, the success of implementing autonomous maintenance, that is JH, is in the success of implementing this sheet. If this sheet is not implemented thoroughly, sincerely, then you can take it that JH is not working in the company. Autonomous maintenance is not working in the company. If JH pillar has to give you the result, this is most important. I can say this is the heart of JH pillar. So we have to give sufficient training in making this sheet and training the operators as how to do this inspection. As we do inspection, we need to do some lubrication. If there is some bolts loose, we have to tighten it. All these activities will carry on. So make this check sheet thoroughly and implement it. We have now come to step 4, conduct general equipment inspection. Till step 3, I can say we are kind of hand-holding the operators to implement JH. Now we have to make them independent. Then only the system can run on its own. So it becomes very important to prepare a good training module. So training, how to prepare the training module? You can take the help of the machine manual itself. During the course of this first step, 3 steps, we would have made some kaizens, and based on that we would have developed some OPLs. And to do training of all these things, try to make a model training station also. A model training station can be made for a group of machines. It may be difficult to make for every machine, for a group of machines, or in fact a section, something like that. So try to make a good training module. That training module will speak about machine working principles of the machine, what are all the safety features involved in that, what are all the kinds of inspection which we should do, why we should do, critical parameters, and the procedure to do inspection. Small SOPs, all these things will be there. In most of the cases, almost all the points can be easily covered if you make a good OPL. A machine can be covered, maybe, let's say one machine with 20 to 30 good OPLs will communicate all the critical parameters of that machine which any operator should know. Second, some of the activities, like let us say fill the oil, how to fill the oil, you can make a video. You have to check the pressure in a given pressure gauge. You can probably make a video. If the click check sheet has got 10 points, probably we can make a video of doing all the 10 checkpoints starting from 1 till 10, which will be a very good a training tool for them. I'm just giving example of all these things. You can think in your own way. The point here is we have to make a training module. Based on this training module, initially we have given some training to the operators, employees, so that they are able to find out abnormalities, they are able to do CLIT. Now they should become independent, rather they should be able to bring out new points. For that we have to give them training. So using the training module what we have made, give them training and test their knowledge in your own way. Probably giving some test or giving some practical test, things like that you can give. You can test them and improve their skill sets from one level to another level to next level, like that. Having done this, involve them, ask them to do inspection independently. A person who is well versed with this can probably go behind and see how he is doing the job. Is he doing the job in the right way? Is it necessary to correct him? So like that, when we observe, we'll be able to do some corrections. By this, we are training the employees with the right kind of input. A job that is a CLIT job to be done, how it is to be done, and it is done the same way it is supposed to be done. So that kind of training is possible through this, and that is the purpose of this step 4. Now we are in step 5. It is autonomous inspection. Up to step 4, whatever we have done is to bring back the machine, restore the machine back to original condition and sustain it at that level so that we get good performance of that machine. All our machine related activities so far whatever we have done. Now we have to move on to next level, include process parameters also, so that the quality of the product what we are producing from that machine, from that process, will also be good. So that is the main purpose of step 5 autonomous inspection, which means we have to now give training to the operators from process angle. Earlier we have given training on working principle of the machine, what to inspect, how to inspect, what are abnormalities, how to correct them, how to implement CLIT, so that machine is protected. When the machine is good, now next is product. So we teach them now, train them on the process. Like for example, if we are doing a drilling with a tolerance of, example, 5 millimeter plus minus 0.01. If this is specification, we must give them a training why that plus minus 0.01 is important. It will have some criticality in that. So from that point of view, we have to give training. Now what causes this? When we are not able to achieve this specification, why it is not possible to achieve? From that kind of angle, we should start giving them training. By that, they will be able to identify quality defects on their own, and if the quality defect comes, they will also understand due to this problem has come, therefore I have to correct that. If they are capable, they can correct it, or else they can call the maintenance department. That's a different issue. But now they start doing inspection with respect to quality of the product also, which that is process parameters. All critical quality parameters, process parameters in that machine will also form part of this clit sheet now. The clit sheet will get now modified, including quality parameters and machine parameters. Up to step 4 we have seen machine parameters. Now quality parameters are getting added. Therefore it becomes a full-fledged clit sheet. We have now come to step 6, that is standardization. It is the time now to understand quickly, briefly about what we did so far from step 0 till now step 5. Initially we formed the team. We gave the training to the team on JH, that is autonomous maintenance. In particular, the training was focused on working principles of the machine, abnormalities, what are abnormalities, how to identify, how to correct them, and then we started doing initial cleaning involving worker up to the entire team, up to manager, even plant head, up to that level we started involving and implementing cleaning. Cleaning is inspection. As we clean, we also inspect, identify as many abnormalities as possible. We also seen guideline to identify abnormalities. We started tagging, recording the abnormalities through red tag and white tag, and we started taking corrective actions. At one stage, entire abnormalities are eliminated. We would have probably left with few abnormalities which require long time to correct, for which we have taken target dates. During this process, we started making lot of Kaizens and OPLs. These becomes very good tool for training subsequently. And at this stage, we have made clit, clean, lubricate, inspect and tighten, including all key machine parameters. As we implemented clit initial tentatives with the initial tentative standard, subsequently we also started including process key parameters into clit system. That is, we started modifying clit with both machine key parameters and process key parameters, and now we are having clit sheet which is implemented with both machine key parameters and process technical key parameters. We are at this stage. Now that particular pilot zone, that machine is working with clearly implemented clit standard, clean, lubricate, inspect, tighten, that standard, involving machine critical parameters and process critical parameters, which means now we are taking care of both machine breakdowns, that is we are preventing forced deterioration and also preventing any quality hazards, quality issues. Thereby, we started, this action will help us in improving both quality as well as machine working time, machine availability. At this stage, we should now start standardizing the activities. So before standardizing the activities, we should Go back and check the entire clit activity and see if there are anything repeating, whether we are doing any wasteful activities. Up as a team, we apply our mind, start reviewing all the activities and try to fine tune, remove all wasteful activities. Thereby, the working method will improve better, and it will take less time to complete the same task. Most important. So basically this step is to review all the activities what we did and what kind of standard so far we arrived at, the tentative standard. On that we review, modify, make the system correct, removing, eliminating all wasteful activities. So at this level, we are having the right standard with us. So now make that pilot machine or pilot zone more visual. We should not be wasting time to identify. That machine, that pilot zone should speak for itself. As we walk, we should be able to identify and understand what it is. One should not spend time to understand the particular component or particular inspection method or particular SOP, whatever it is. Nobody should spend time to read and understand, but as they see, they should be able to understand quickly, which means it should be pictorial and it should have only few words so that in no time they will understand. So that's what we reach in step 6, that is standardization. How to make the parts, components, machine, that zone more visual, let's see in the other slide. Okay, why we should make the machine components, pilot zone, all that area more visual? If the plant area is more visual, it is self-explanatory. Anybody can walk in to any place on their own, number one. Number two, if let us, for example, we are asking a person, go to so and so area, he should not be in search of that area. Instead, the direction given there should easily lead him to exactly the same point. Like the Google map, we should be able to reach to that location on our own. So no wastage of time. Nobody is going to spend time on this. Next, we need to do some inspection of a component. Let's say oil level to be inspected, example. We just have to go and see in few seconds, 3 seconds, 2 seconds, like that. So instead of checking through a dipstick, remove the dipstick, see the level and put it. Instead of that, just by seeing, we should be able to understand oil is okay. So that kind of level indicators with visuals. Like that, if you make the time taken to reach any location, time taken to do any activity of clean, lubricate, inspect, tighten, that kind of activity will slowly keep on getting reduced, and you will reach your optimum level where you will spend very negligible time to do all these things. As a result, even if there is a major job, major preventive maintenance job, etc., even that job will take less time to implement. Now, as we make more and more visuals on quality standards, as we keep on seeing, because they are effective OPLs, we don't spend time on that. Quickly they grasp it. In no second they will grasp it. Therefore, it goes into their subconscious mind. As a result, in the long run, they will never make mistake. Operators will always do right job only. Do it right at the first time itself. Therefore, we will not make any quality problems, quality accidents, nothing will be there. So like that, there are many advantages we can keep on listing. I don't want to keep on going into that aspect. Let us see here some idea how to make the machine components more visual. Now the color coding of lubricant, pressure gauges, thermometers. The right side I have given one oil indicator, level indicator. If let us see if there is no color coding there, you only see the oil indicator. One has to go near that and read what is minimum, what is maximum. Like that, one has to read and understand the oil level is correct or not. Whereas when you give that red color and green color, some cases we also used to follow yellow color. I don't think it is necessary. These two colors are good enough. Okay. Now green color is there. As we see oil level at any point of green color, it is okay. We just have to go away. So it is so easy. So now next one you see bolt and nut. In cleat there is T. If there are any parts which is loose. See, the critical nuts, as we move, the nut is the movable part. It can get loosened. Whereas the body just below the nut is a stationary part which will not move. So with the movable part, nut, and stationary part, the base, just make one line, joining line, any color which you like. So if that line is matching, nut is intact, no loose, not got loosened at all. If it is mismatched, it is very clear, it is loosened. All of us know this. Just I am reiterating that. So what happens? We don't spend time to see whether the bolt is loose or not. It is also visual. It is also helping us to do inspection quickly, effectively. Like that now, you see the next one I have given here is gear rotation level, direction of rotation. It is very, very important. Gear rotation, motor direction rotation, sometimes rolling rotation. This is all very important. What happens whenever there is a major issue, breakdown, after correcting that machine, there are occasions when the direction is changed because of electrical connection change. The entire performance will be out. So it is very important to see the direction of rotation. So they need not search and think what is the right direction. Just by looking at the arrow, what is drawn at that nearby parts area, you can understand that. So that direction of rotation. So like that, suppose there is some area where you need to use tool, spanner. You show the spanner, at least they will bring the spanner and check that. All the more it is important, near that machine, there should be a board, display board. Whatever the tools are required, those tools should be displayed rightly in that place, so that they don't go in search of the tools required for doing clit. They simply pick up and do the job in no time. The motive is this: we are able to communicate what it is. Now no training is required. It is self-training. They know bolt is loose or not. So it is self-directive. They don't spend time. We can quickly do the job, and thereby we can prevent force deterioration. Like this. Now whatever here shown here is all engineering technical related items are shown. So there is a pressure gauge. Let's say the pressure required is 7 kg plus minus 0.5. So between 6.5 and 7.5 kg, there should be a green mark. Balance everything should be a red mark. The needle is at that location, fine. In the digital world, you can even say that digital, when it is coming between 6.5 to 7.5 kg per square centimeter, it should display in green color. It is anything beyond this, it should display in a red color. Display itself will be in that color. So we can modify as we are improving. we should also modify our coding system, color coding, the color indicators, so as to easily help us to identify fast, take action fast. After completing this, when you walk around that pilot zone or that pilot machine, even a new person to that area comes there, he will be able to identify what is required on his own. Now, it creates a kind of good motivation, impression for the person who sees this. A motivated mind will give us good result. Quality of the product will also be good. Good productivity also we can achieve. This is most important step. We should not miss out even one critical parameter out of this. Each and every critical parameter should be displayed, identified through this color coding, through visuals, so that we don't spend time, which helps us indirectly to avoid, to stop force deterioration and to stop quality accidents. Thereby it helps us to increase availability of the equipment and makes the quality excellent. We can reach zero defect through this kind of methods only. We are now into the final step, most important step, that is step 7 of autonomous maintenance, that is JH pillar. It is autonomous management, that is self-management. Operators, workers manage on their own, that is self-management. They manage their zone automatically without the support of anybody else. The operators owns that place, that workplace, and they are able to manage on their own. During the course of implementing this step 0 to step 6, they already developed, the operators who are working on the machine have developed enough and more skills to do this. We can also check this, if need be, give more training, particularly on problem solving skills. Take the past problems, take all the repetitive critical problems, you give them a kind of training, make them to analyze, make them to come back with the solution. Like that we can train them. There are 101 methods of training. I don't have to explain that here. What is more important is, though operators working on the pilot machines would have got developed required skills to solve all day-to-day problems, in this step, please recheck and ensure that, if need be, give training again on the problem solving skills. Number 1. This helps the operator, and operator owns his area. He ensures that his area is waste free and problem free. In fact, if you are able to succeed and achieve sweeper free zone, it is excellent. The operators, supervisors, managers working in that zone, a kind of culture is imbibed into them, it is seeded into them. They always think improvement is their routine activity. It is no more a special activity. Every day they will keep on thinking. Any small problem comes, their mind will keep on working. How do I eliminate this? What is the root cause of this? Their mind is already in improvement zone. Therefore, the improvement culture is set in there. Now, at this time, every company will have the company goal. So, every pilot machine will also have improvement goal. This improvement goal should link with the company goal. Therefore, it is easy for the company to achieve the company goal also. So this is the most important step. This step helps that zone operators owns that area and it is their machine. They manage on their own. They don't need anybody, any other support. But as a management people, supervisors, managers, all at this different level people should keep an eye on this and facilitate them to do this successfully, continuously. From step 0 up to step 7, we have seen how to implement autonomous maintenance, that is JISHU Ocean JH pillar. Briefly, we formed the team. We have given training on JH, particularly on abnormalities and machine working principles. We have selected a pilot zone or pilot machine. We started implementing initial cleaning and inspection. As we inspected, we found a lot of abnormalities. We tagged them with white and red color. We logged them, started taking corrective action, given the training to the operators to do corrective action of these abnormalities. They corrected it. At the end, we have now no abnormalities. We reach that level. We need to now maintain that machine at that level. So what we did, we implemented CLIT, click sheet, incorporating all machine key parameters. Subsequently, we included process parameters also. As a result, click sheet has taken a final form, both with machine parameters and technical quality parameters. Thereby, we stopped forced deterioration and improved quality. Rather, we stopped quality accidents. At the end of this, we made that respective machine operators, workers to become independent. Now they are owning that machine. It is their machine. They are maintaining without the support of others. As management, we should keep on having an eye on them, extending support, facilitating them at this level. Now all the 7 steps of JH has been implemented. That area will look self-explanatory. It will speak for itself, totally visual with a lot of OPLs and Kaizens. Every component which is to be inspected through kit has been identified well with visual indicators, color coding. Now, how to understand current status? Now, one of these 7 steps, it is not that you will be strict. As we start implementing, we are extending to other zones of the company. Sometimes some of these steps can be merged also, no harm in it. Okay. Now, it is now in all the areas. How to understand where do we stand? What is the current status of autonomous maintenance implementation? That is, where do we stand with respect to JH pillar? So, every zone should have a display board. That display board, what all should be covered in the display board? I have a separate slide, I will show you there. Based on near the display board, involving that team member, that JH team, which we formed in the beginning itself, entire team should have a daily meeting. It should not be more than 5 or 10 minutes. The longer the meeting in the shop floor, in this kind of area, will not be effective. Please take it from me. It should be quickly. This is only to discuss day-to-day issues, not otherwise. How are we progressing in JH? Where do we stand? Is there any problem? What kind of support we need? it is in that kind of matter we have this kind of meeting. So it should not be more than 5 or 10 minutes. And here you cover all critical parameters, all key parameters. You have to perform all we call now performance indicators. Performance indicators with respect to safety, productivity, quality, S, P, Q, D, C, M. You cover all the points and conduct meetings here. Now, the machine has reached a level, we have to certify these machines, these zones, whether it is really meeting the standard that is required. We have set up the standard. We have made, initially we have made this tentative standard. As we move on, we kept on correcting the standard. Now the standard has become the right standard. So you audit through set norms, set standards. It is audited by first the team who are working in that area only. It is called a self audit, first level audit. They audit, they get satisfied for themselves. Then they call the JH chairman. We have seen this structure at the beginning of the training module. So this JH chairman comes and audit from his point of view and improvement takes place. Once he is also clearing this level, final audit, it has to be done by the TPM manager who is coordinating the entire company. He will also be accompanied by plant head, or plant head can do separately, independently also. So during all these 3 steps, 3 levels, if the machine is cleared, if it is left with only 1 or 2 issues which you can re-audit and correct it, then we have reached a level where JH is in practice. Most importantly, during this audit, the operators who are involved, their involvement in the machine activities, their involvement in implementing CLIT, their involvement in bringing up the Kaizens, OPLs, things like that, this is to be tested. Because without their involvement, this cannot sustain. So during the audit, don't simply audit only the machine parts and process requirements with respect to standard. Most importantly, test the involvement of the operators, workers who are working in that zone. We said every zone should have an activity board and there should be a daily 5 to 10 minutes meeting conducted for improvement, progress, understanding. That will help us to know the current status, and as any support that is required, we can monitor that. So what all to be displayed in that display board for us to get good results, so that we can understand, are we on the right track? JH starting itself, we said we'll find out abnormalities and identify them through white tag and red tag. So it is necessary automatically to monitor the trend of these white tags and red tags. As we implement CLIT, naturally lubricant consumption would have come down. So we need to monitor that trend. As we are implementing CLIT, minus stoppages will come down. Why? Forced deterioration is not there now. Therefore, minus stoppages trend. As minus stoppages are less, production, there should be improvement. Therefore, production plan versus adherence, we have to now see the trend. As machine is not stopping, it is kept on running now to the maximum with the same time, within the same manpower. We are also now producing more. Therefore, productivity will be more. So monitor the trend and see. As CLIT sheet includes both machine parameters as well as quality parameters, that is as well as process parameters, rejection should come down. So monitor the trend of scrap and rework. While implementing JH pillar, we started making lot of OPLs, lot of Kaizens. So monitor the trend. Making OPL is alone not sufficient. We have to give them training. Without giving training on OPLs generated, the team will not have the current knowledge, current skill set. So audit on this OPL training also. While doing all these things, these will automatically help us to make that zone more safer. Therefore, there will not be safety issues. Monitor all these things as a trend and display them, group them and display. Most importantly, clit adherence schedule. If the clit is not adhered well, I mentioned earlier also, then JH is not implemented. If any company can say that we have implemented JH, that is autonomous maintenance, means in that company, most importantly, clit should be followed 100% without any failure. So monitor that also. Therefore, all these things should be displayed in that activity board where there will be daily meeting of 5 to 10 minutes. Now we have reached a stage where we have to set up the targets. In the beginning itself, I mentioned normally targets should be set the beginning itself. Before taking up JH or autonomous maintenance, we should set the target and then move on. We are not going to do any project for the sake of doing it. So we should set these targets the beginning itself. However, we have kept this slide at the end so that now all of us are having clarity in our mind as what this autonomous maintenance, that JH pillar, will do for us. As we are having clarity, it is easy for us to set the target. Now that you have the clarity, you can set the target and move on, start JH in your company. Let's see. JH, we said it is going to eliminate leak. Therefore, we have to take a target on lubricant consumption, be it oil, be it grease. Normally, minimum of 30% reduction will be a good number. During the process of implementing JH, we have eliminated all those unwanted activities, wasteful activities. While setting up clit, initially we have taken tentative standard, then we have reviewed, we started eliminating wasteful activities, we started doing that. Therefore, there will be improvement in reducing process time. So we have to take target there. Next one is minor stoppages. JH stops, clit system stops forced deterioration. Therefore, minor stoppages. What are minor stoppages? 2 minutes, 3 minutes, 4 minutes stoppages. Na? Those things are minor stoppages. Those things will get now eliminated, or it will be very negligible. Once in a blue moon it can come. Normally it should be 0. As we are doing clit both on machine key parameters as well as process key parameters, quality will definitely improve. Therefore, on quality levels, as the places become now well organized, the place is neat, well organized, there are no chances of accidents, safe atmosphere. So we should start taking targets in all these things. Now JH helps us to improve availability also. It helps us to improve productivity also. It helps us to reduce rejection also. And therefore, OEE will also improve while implementing JH, because OEE is function of 3 parameters. You can visit PM pillar video to understand OEE in detail. So in all these areas, we can take the target. You know your company, study your company, understand now what JH is, link these two, try to set targets. These are the guidelines what I have given here. Based on this guideline, you can set the target and move on for implementing JH. We have now seen how to implement JH, that is autonomous maintenance pillar. We also understood what kind of benefits it can give us. So what is next? We should never stop. Go ahead, implement. And JH, PM, both the pillars jointly can do wonders for the company. And JH and PM pillar are the heart of TPM. Go ahead, implement JH. TPM is not a one-time project. It is a journey. We can't do this TPM implement and stop. It is not a destination. It is a journey. And autonomous maintenance, JISHU Hosen, that is JH pillar, will help us not only to achieve manufacturing excellence, but to sustain. How? By involving the entire company employees. Total employee involvement is ensured in this system. This structured way of doing TPM will definitely help us achieving world-class manufacturing. Therefore, go ahead, implement and do it. You may contact for any clarifications.